Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss fitting sinusoidal curves to data. We have a table here on the left where we have the times and the height of the tides in feet. So time t equals 0 corresponds to where we start, and then 1 corresponds to an hour. So after an hour has passed, this is what the tide is. After 2 hours have passed, the tide is 5.721, etc. So in this problem, we are going to create a model using the cosine function based off this data. And we're just going to go through it step by step. The first step is to find something called the vertical shift. Vertical shift. And the vertical shift is going to be b. So b, actually it's equal to, so let me just put an equal sign here. It's equal to b, which is equal to, and there's a formula. The formula is 1/2 parentheses, and it's going to be the maximum plus the minimum of your data. In our particular case, it's 1/2 times, and so the maximum in this case, let's identify it because we're going to need it. It's up here. It's 8.128. That's the max. And the min is down here. It's 0.902. That would be the minimum. So we have 8.128 plus 0.902. And so if you put this in your calculator, you end up with b equals 4.515. That's going to be our value for b. So to find the vertical shift in your model, you always just do 1/2 times the max plus the min. It's pretty easy once you know the formulas. The next thing we want to find is something called the amplitude. So the amplitude. And so the amplitude is going to be A. Okay, it's A. And in this case, A is 1/2 in every case, actually, because it's a formula. So it's 1/2 max minus min. But in this particular case, we have these numbers. So it's 1/2. Then your maximum is 8.128, good stuff, minus the min, which is 0.902. So it's pretty easy, you just have to use the formulas. You plug this into your calculator, and so you get A equals 3.613, very nice. You find the vertical shift, it's 1/2 times the max plus the min. Find the amplitude, it's 1/2 times the max minus the min. We need the period, this one's a little bit more difficult. So the period is equal to 2 pi over omega. So really we need omega because omega is what we're going to plug into the formula. So this is actually equal to 2, and then it's going to be the time of the max. So time of max minus the time of the min. Okay, so you subtract them. So for us, it's going to be 2 times, well, the time of the max is 0 using our chart, and the time of the min is going to be 6 using our chart. It's just going to be -12. So now we have an equation, right? We have 2 pi over omega, and that's equal to -12. So we have to solve for omega. What we can do here is we can multiply both sides by omega. The omegas cancel. We have 2 pi equals -12 omega. Then divide by -12 and you get omega equals -2 pi over 12. And if you put this in your calculator, you end up with omega equal to approximately, so this is an approximation, so approximately -0.52. Okay, that's going to be our value of omega. It's not going to matter that it's negative because cosine's an even function. So even if you put a positive here, you would still get the same result at the end. So it doesn't really matter. And now we just need the horizontal shift, and we can plug everything in, and we have our trigonometric model. So the horizontal shift, and it's nice because these formulas always work. You can always use these formulas and things will be good. So the horizontal shift is basically C, your phase shift, and it's going to be the time of the max value. A time of the max value. In this case, that's equal to 0. Okay, so c is equal to 0. So now we have everything, we can plug it in. Let's go ahead and write the model again down here. I'm going to scroll down and write it again from scratch. So we have y equals a cosine, parentheses, omega, t minus c, and then it's plus b. So y equals, so the amplitude was 3.613. We get 3.613. And then we have cosine of omega, which was negative 0.52, parentheses, t minus 0. And b was 4.515. It's at the very beginning. 4.515. 0.515. So y is equal to 3.613 cosine of, and then this negative is going to go away. We're just going to get 0.52t because cosine's an even function, so it doesn't matter. You could leave it if you want, but it won't affect anything. And 4.515. And that would be our model that models this data. This data is actually data that was created using another model, which I don't know. And it's actually real data that was created just a few days ago from the making of this video to model actual ocean tides. And let me actually show you how good our model is. I'm going to show you graphically what this model looks like and what the data looks like. You're going to be shocked at how good the model is. It makes me wonder if this data was generated using this particular model or something very, very similar. So let's go ahead and check graphically to see how good our model is. It's really quite interesting. Okay, so check this out. I've got my old calculator here and I've plotted the data and I've plotted the graph of the cosine function. So I'm going to turn it on and I'm going to go to my graph. I'm going to hit enter and I'm going to hit graph. Watch this. Look at that. You see our data points and you see the graph we just created. So it's pretty much, it's almost a perfect model. Not quite. You can see there on the right that the curve goes above some of the data points. So almost perfect and really just really impressive and how good our model actually is for this particular data set. Really amazing. Really cool that our model was so good. And again, in order to do this problem, all you do is you just follow these steps. You find the vertical shift using the formula here, 1/2 times the max plus the min. Find the amplitude, which is 1/2 times max minus min. Find the period here using this formula, 2 times the time of max minus time of min. Then solve for omega, and then find the horizontal shift, which is the time of the max value. And then you just plug everything into your function and you have your model. So really interesting, really cool problem. Hopefully you've learned something in this video. And if you enjoyed this video, make sure to check out more videos on Chegg. Until next time, good luck and take care.